Here I've got a mass M, an unknown mass M, supported by a couple of cables that are attached to both a wall and a ceiling with the angles of 50 degrees to the ceiling and 60 degrees to the wall. We know the tension in one of the cables is 500 newtons, and the question is, what is the value of this hanging mass? We're trying to figure out M. Now once again, all these forces converge to this point, so I'm going to make that my free body diagram. On that point, I've got a force of gravity that's straight down. That's in fact what we're going to look for. So if we find Fg, we can figure out what M is. There's a cable with a rope pulling it to the right, pulling that point to the right. Ropes always pull. So I'm going to call that T2, tension 2. There's also a cable pulling it to the upper left, which we'll call tension 1. Now it's not moving. So we know that my net force must be 0, which means the sum of all the forces acting at that object must add up to 0. So in other words, T1 plus T2 plus Fg must add to 0, but they must add as vectors. So tip to tail. We have to construct a tip to tail diagram so that they add together to equal 0. So let's have a look at our picture and construct our diagram. Start with T1. So I've got T1, fairly steep, something like that. There's T1, pulling the object to the upper left. At the tip of T1, I'm going to start my next vector. T2, now it's a shallower angle, so I'm going to make it go a little bit low, something like that. And we know it has to end directly above this point because the force of gravity has to be straight down. So I'm going to make sure my arrowhead is directly above that dot, or as close as I can. So this is T2, and then at the tip of T2, I'm going to start Fg, which is straight down like that. So there's my sketch. Now we know one of the forces, T1, happens to be 500 newtons. We also know some angles, which we'll label right now. We know that 60 degrees is the angle between T2, there's T2, and a vertical surface. So this angle right here is 60 degrees. We also know that T1 makes an angle of 50 degrees with the ceiling. So this angle right here is 50 degrees. Now if I draw a parallel line through the center of our free body diagram, if that's 50, then this is also 50 down here. So right here, that's 50 degrees. And since Fg is straight down, this angle inside the triangle is 40 degrees. Now, angles inside a triangle must add to 180. So if I've got 60 and 40, that adds to 100. That makes this angle right in here the rest, which would be 80 degrees. So I've got a triangle where I know all the angles on the inside and I know one side. So I'm going to use the sine law to finish my question. So we're trying to find Fg. So I'm going to put Fg at the start of my sine law. Fg divided by the sine of the angle opposite to it. So there's Fg. The angle opposite to it is 80. So Fg over sine 80 equals, now I want to use my known tension, equals 500, which is T1, divided by the sine of the angle opposite to it, which is 60 degrees. So divided by sine 60, and that allows us to solve for Fg. So Fg will be 500, when I multiply both sides by sine 80, 500 newtons, divided by sine 60, multiplied by sine 80. That'll get Fg by itself. Now when I do that, I get a force of gravity of 568.5 newtons directed straight down. Now if I want to find the mass, we know the equation for force of gravity is mg. Dividing both sides by g, which is 9.8, will give me a mass of 58.0 kilograms.